Loop statement is used to process a group of SAS statements multiple times. Using loops can greatly reduce the number of statements required for repetitive calculations or reading huge data sets. The syntax for using do loop is as shown. Here, the index variable stores the value of the current iteration of do loop. An already created variable is eligible to become the index for do loop. The start value specifies the initial value of the index variable. The stop value is the last index value that executes the do loop. The optional by clause specifies an increment value for the index variable. If by clause is not specified, the default increment value is 1. It is important to note that the start, stop, and increment values are set upon entry into the do loop. They cannot be changed during the processing of the do loop. They can be numbers, variables, or SAS expressions. The end statement terminates the loop. The value of the index variable can be changed within the loop. In the next screen, we will observe an example of do loop. The example will calculate the amount of interest earned each month for a one-year investment by a person. During compilation, the program data vector is created for the finance.earnings data set. When the data step is executed, the values of amount and rate are assigned. The do loop is executed. During each execution of the do loop, the value of earned is calculated and is added to its previous value. Then the value of month is incremented. On the 12th execution of the do loop, the program data vector looks as shown. After the 12th execution of the do loop, the value of month is incremented to 13. Because 13 exceeds the stop value of the iterative do statement, the do loop stops executing, and processing continues to the next data step statement. The end of the data step is reached. The values are written to the finance.earnings data set, and in this example, the data step ends. Only one observation is written to the data set. However, there might be a situation when the user wants to store earning for each month individually in the resulting dataset. In such a case, explicit output statements are used with the do loop. We will discuss this in the next screen. Default data step contains an implicit output statement at the end of the step. But placing an explicit output statement overrides automatic output, causing SAS to add an observation to the dataset every time the explicit output statement is executed. For example, if we use the explicit output statement in the do loop as shown in the program, calculations for each value of the index variable will be stored separately in the output dataset. The output will appear as shown. So far, we discussed how a do loop iterates with an increment in the index value in each iteration. However, you can control the flow of loop and some other methods too. We will discuss these methods in the next screen.